How do you go about making the berm? How do you go about making a spot elevations as accurate as possible? The bioretention should not stay square. It should be curved. It should be, depending on where they are. Usually they're a enclosed eclipse type of shape. Let's see. You have 1, 2, 3. We'll start with the bottom one. My control is not. Give me a second. Come on. Yeah. Use that one. Okay. So we have this one. Your spout elevations are definitely too small. Yeah. At print size, I should be able to read. Okay. So the first thing I'm actually checking is whether your CC is correct. But the CC should be lower than 1105, right? How do you know that? You would measure this distance. You would measure that distance from here to there, wherever. Well, you should put the curve cut at the lowest point. The lowest point is the tender point, where you have the largest. So basically, you go from the center of the circle, you project a perpendicular line, and this is where you have the lowest elevation, right? If you don't have your curb cut at that location, you'll have ponding water, just because things will keep flowing from your curb cuts to the lowest point. It will pond there, right? You need the DI in that case. So this would be a curb cut / DI, right? Well, if you have an overflow in your bioretention, then you don't need the DI. You just need either one of them. You just need to make sure the excessive water has somewhere to go. So you can direct them to a DI. Basically, you would have, these are curb cuts, and then in the middle, at a lower location, you have a DI. That's how you draw it, right? At either side or both sides of the DI, you would have curb cuts. Things go into the curb cuts first, but when the curb cut gets full, it flows into the DI. Or you can have a curb cut, but you have an RDI at the lowest, but you have an RDI close to the entrance. Okay, either one of them would be fine, because this is the end unit, right? You don't have anything else downstream. So that's the one that you have to have an overflow mechanism there. Okay, so this is so your CCN or DI would be here, and then you would measure the distance from this line 105 to your curb cut or DI. And if the slope is 2%, you would use that 2% and the distance to get to your elevation difference. So it's 1104.15, for instance, or 85, sorry. So we can estimate 1104.8, something like that, right? Okay, so I don't want to delete everything. I'll do that one and that one. Once you have this one, and so the curb cut is always the bottom of the curve. Does that make sense? So you have CC, but you can have another TC. Except here that you have an opening, so you don't necessarily have the TC. So basically, you can write CC 1104.8. Okay. And then that's basically your water entrance, right? So your LP would be about a foot lower than that. You can make it shallower, but it's about 1 foot lower. So it's going to be 1103.8. And then how do you go about making the berm? We'll have to look at, the surrounding contours to be able to know, okay, so I have 1104.8 here. And we have another 105, that's 05. So this is a 05, right? If you have an 05, and this is at 1104.8, you would have another 1104 at kind of in the, so we're not drawing the boundary of the retention, we're drawing the contours so that they don't cross your contours. Does that make sense? So that line, the line that you drew here, it is not the boundary of the bioretention. It is contours. So this is a grading plan. It doesn't, no, you don't have, because there's no material differences. I mean, well, the key point of the drawing is to show elevation changes. So no boundaries that indicate in the bioretention area, there's no boundaries indicate where kind of you have scoped, the scope of the bioretention is, right? So we will need to modify this. We can have this one go, let me change a color. We can enlarge that one if we want this to be bigger, for instance. So that's my other 1105. This is my new 1105. And then I have a 1104 because your bottom is 1107. No, 3.8. So you have a 1104 in between. Does that make sense? So yes. You have another 1104 here. That's the contour that's going around. And the 104 would not be intersect with your curb because the curb elevation here is above 4. Okay, it's an enclosed line instead of hitting the curb. Okay, so I'm gonna erase that one. Now, if this is 04 and that is 05, you don't necessarily need a berm because it's already enclosed. So for this one, you don't need a berm. All right. Only if you have your 05 hitting the curb over here, if, for instance, you want your 05 to do a different thing of hitting here, then your 04, well, you have another 05 over there. So either way, you would need a berm here, but you will have another scenario in another location where you would need a berm. Okay, so it's really determined by what your adjacent contours are. All right. So for this one, you have the DI and the CC and the low point, and then you need to add another contour number, 1104 here, and then that's it for this one. Okay. Oh, your low points. So remember that the design of the bioretention, you're supposed to make the bottom flat because you're encouraging vertical flow. So you will evenly distribute your low point. So you will say 1, 2, 3. So this makes sure that all these points are the same elevation. So the contractor gets the idea, oh, it's supposed to be flat. Okay. All right. And another thing is make sure that distance is over 3 because we want to make it lower than 3 to 1 slope, 33% slope, right? It's better if you make it larger, like a 2.5 to 1. Basically, that's 4 feet apart, 25% or even more shallower. Okay. All right, so I'm gonna clear this part and then I'll navigate to another location. This one. Okay. So for that one, again, we need to remember that we don't have a curb here anymore. Okay, there's no curb here. So when you have a contour hit here, you're indicating that you actually have a wall at the edge of the pavement. So for this one, you also wouldn't have a shape that it's actually hitting the wall and being cut off. You will again have an enclosed shape as your retention. Now for this one, you're just, it's the same thing. You would measure the distance from here, from wherever this, actually you want the entrance to be on the swale because that's lowest point. And then you would measure the distance from here to there, okay? That's your, the integral contour. Don't know the number. Let me zoom out and find out what the number of that contour is. So you have 1107. Well, I'm not exactly sure. This is 6. 8, 7. You have another 7 over here. That's 7. So this would be 7. If this is 7, means that one is 7. Is that right? Yes. And 6. 6 seems to be not parallel. This one, if you move it over, yeah, I think we are, we need to double check this line and that line, okay? So if we have 7 here, you measure from the swell point to the 7, and you used 2%, and then this one appears to be pretty close to 6, okay? Because the distance looks pretty similar to this one. So you're getting about 1106 at that point. Okay, so we will get down to that area. Well, suppose that, no, we are at 1106.25. Again, you don't have a curb here. It's not a curb cut anymore. It just flows down the surface, right? It's a swale without a curve. There, you just need to mark the elevation, no CC, no TC, okay? And we have our LP. That elevation is fine. Just basically mean you don't want it to be deeper. Now you can have it less than 1 foot deep. And then, so let's cross that out. The TC, cross it out. You would need an RDI. You will need an RDI. So the RDI, well, now your RDI is only 0.05 above your LP, meaning that almost all the water will just go to the RDI. So let's try to draw it out, and what the in this case we have a parking lot, no, plaza, right? And then it would just get down into a retention area, and then you might have a shallow vegetated slope getting down, and then that's your bottom, and then it goes out somewhere. There could be a berm, but we'll have to see. Now, again, drawing in cross section, right? So here, that's the plaza edge. If you have 1106.25 there, if your RDI would be still a tad lower than that, so your water would be at about this level, 1106, for instance. Let me change to a blue color. So if that's your RDI level, and that's how much water will be able to pond over there, right? So the RDI, it's right there, and you would have your RDI equal to 1106. Does that make sense? And if that's the case, your LP, if you want to make it 0.5, would be 1105.5. So it wouldn't be 1105.70 corresponding to your 105.85. Basically, that means your depth is 0.05. You won't be able to hold any water. So if you have an RDI equals to that, you would know I would have a 1106 contour, right? Your 1106 contour is basically, doing this. I wish I can do a better shape. Well, maybe I should just hand draw. You would just have a 1106 like this, okay? That's your 1106. That's your 1106. And now we'll zoom out and see where your 1106 is. Looks like that's your 1106. You have a 1107 there, right? So it looks like your 1106 goes around the area like this and then hit the wall somewhere like that, right? If that's the case, you need a berm now, right? So basically that's the contour here. The 1106 goes right there. And your berm will be between these two so that the water will not flow over. And you have the right location for HP over here. You would move the other HP to somewhere here, okay? It will be between your blue contour 1106 and the other 06 wrapping around the other side, okay? So those are where your HP would be. You could make it 06.5, right? So that the berm, it's pretty gentle as well, doesn't get too high, right? So that's basically it. You add that one, revise the LP, revise the RDI, and have the contour number labeled, have the HP, and then this one is done. Okay, so when you get confused, when you all kind of get confused, what scenario I am at, am I at the plaza edge or am I at a different location, draw a cross section. That will help you, understand where do I have contours, what the LP needs to be, where the RDI elevation should be. Okay, so that's this one. Okay. We have another one over here. That's probably one of the more standard ones. Again, these would not cross the other contours. We have the same error here because now we're getting down. So you need to minus 0.15. So it's 1107.75 or 85 here. So the CC would be lower. Let me try to move over. So let's see. 107.85. Then this is not the final cell. If water stops getting in, it will keep flowing down. So you don't need a DI, you don't need an RDI here. You can, of course, you can put it in. You can put it in, but it's not necessary. Okay. So the key thing here is your LP. So for instance, if you want to have your LP that low, you can see that your water level exceeds 1 feet, right? That just means you have a pretty deep cell. So in this case, I'm gonna again draw the curve over here. And the curve right now is at 1107.85. But you want your water, the bottom of your water to be, it's not like you can't do that, you can, but you wanna make sure that other things are correct, corresponding to your design of your LP, right? Your LP is 1106.20. And in order to make your depth within 1 foot, the elevation of your water needs to be what? Needs to be 1107.20. That makes sense? So that's where your RDI would be. In this case, if you want to design LP to 1106.20, you need an RDI, okay? But if you don't want an RDI, you just put your LP at about 1106.85 or above that, then you don't have that problem. So this just means that I'm creating a pretty steep slope or a deep cell that looks like this, right? If I don't want that to be this deep, I could move these lines up. Does that make sense? Basically, if I don't want that to be this deep, I don't need this. I can keep the water level just at the curb cut level, and I just move the LP up. and then I have a less steep depression. Okay, yeah, so that's you just need to make all the numbers work together. Okay, so if that's the case, if we are revising this to be 1106.85, we know that we have a 1107 contour, right? Yeah. Set contour, doing this. And then we just need to look through the surrounding contours. We have a 07. Okay, this is, you have another 08, let's see. So your 8 goes here and then cross the curb and goes like this, and that's your 8, right? So if this is the 7, you don't need a berm. Well, let's see. Unless, well, your 07, it's actually, well, I need to zoom out again. Let me zoom out. Your 07 is not connected correctly because, well, I guess I'll need to clear everything. That's okay. So 07 goes here. This is a closed one. And 07 does its own thing. 09 goes here and goes there. You might want to cut these to the kind of closest to the vegetation because you need space here. So you need to change, for instance, your 1112, like doing this, okay? Yeah, move them over, because all these places, you would need retention area, right? You would need a few more here. So you need as much space as you can. Let's erase that. Now, our 1109 goes, let's think through this. I want a cell over here. So I want something at the bottom of this space. And then my 07, yeah, these are related. So I'm trying to think about the big picture. This one can hit here, and then continue to connect to the original 7 that I don't, yeah, 07 is over here. Or let's see, 7, 6, 7 should be above. So 7 would go something like that. And then over here, you would have another one. Over here, you would have another one. Yeah, let's switch your direction of the swell to the, I think this is about right. If that's the case, we'll turn it a little bit because we want to turn the swell direction away from the building, right? So if that's the case, you have another one somewhere here, okay? You have 2. One is trying to get water from the dirty turnaround. The other one is along the swell off the pavement, trying to treat the plaza water relatively clean, okay? So that's the one here. And then we have, it's a little bit better if you move this down because, move down here, because everything else, like all the excessive water will come over to the bottom red one. So if you can put your green one closer to your red one, you can carry a little bit more load than if you had one kind of more upstream, okay? So it's better if you have your retention over here. And then that you will have a curb cut somewhere there. That will be close to 7. So you would have a 7 point, for instance, 2 there. And your 1108 goes around 1. color. 1108 goes like this, wrap around, and then your 07 goes, so this will be a 7, and then you would have middle, in the middle you would have some high points. Does that kind of make sense? Yeah. So at this point, you all did 3, which is great because you're learning about how to do these. But then once you get to doing everything, they need to work together instead of saying, okay, randomly I put 1 here. You look around and see what are the locations that make the best. But by that time, you already know how to do these things, right? Then it becomes pretty fast. So don't worry if I say, okay, this one doesn't work. It's now you just need to shift it to a different location and calculate again. It's really not a huge effort to change. Okay, so that's your 3 cells. Sure. No, because you are drawing the contours for the bioretention. The contours don't cross. Okay. Yeah. Move the other ones. Move the other ones. So for instance, all these needs to move out of out of the green. You would cut, you would, well, maybe this one, this one would be okay, but here the 13 would be cut short. Yeah. So instead of having 12 at this location, you move it closer to the vegetation. Yeah. Okay. Good. All right. Look. Yeah. I know Sarah's online. Is there any other, let me double check the other room, if there anybody else that needs to be assigned to my room. How can I see that? Breakout rooms. Yeah, assigned to me. All right, I think we're fine. Okay. Sarah's over here. Good. So I'm confused on how to draw these contours of dropping the parking lot. The red parts, okay. And then you had 3 areas. How would I add bioretention areas to the spaces that are already open between the bus stops and parking and the 2 parking lots? Oh. Here, because you're directing water away from that green area, you actually don't have any bioretention in there. Unless you turn, well, you have some, so we'll take a look at that. You have some water going in there. Yeah, I don't know if it's worth modifying the contours anymore, but you have a portion that goes into the green. Let's not do radical things at this point. Okay, we'll take a look at the contours in this area first. Looks like you have originally had this one and that one, and we will move one of these to somewhere here. That looks like, oh, you turned. Okay, some of your contours turned, which is fine. So these ones, that is corresponding to that one. So this is part of a transition area. That's okay. If you don't have plaza here, you can actually be steeper. So that one would actually go something like this. And then essentially this is your 07. And no, okay. I'm confused. There might be one off. This one would be 08. This is your 08 actually. Well, let me zoom out, okay? Zoom out because I want to make sure that's correct. So that whole thing is 1, 1, 1, 1. And 1, 1, 0 is over here. Draw. Yeah, you had one leftover line over there. That's your 0. That's your 0. Okay. Then correct. Okay. We are missing one over here. That goes somewhere there. Goes a curb. Okay, now I'm getting up the curb. So this is a little confusing. Okay. We try. These are original. That one is going. That goes over there. This goes. If there's no. Okay, so that is your closed contour over there. If it's less than 25 foot from the other places, from the other adjacent contour. Second. So that's 09. That's 10. That's 08. And this is another 08. Yeah, that's correct. Because I can see the other line, it's not hitting the curb. So that's correct. So we have all these contour. These are 08. All right, and then we'll go to your 07. Yeah, change the color. And that one can go hit the wall like that and go around this, and that's your 07. You would have another 06. You have another 06 over here, and that's depending on whether this is over 25 foot. It could be a closed contour. You do need to measure that. Okay, measure if this is 25. If it's over 25, then it branches out. But if it's less than 25, you have a closed contour. Okay. Let's see if there's anything else that's missing. Oh, my bad. I see that you have something here. That's correct. You go like that, and then you go around. Yeah, that's about. Other things are correct. So 7, 6. So the contours should be like this. Any questions about the contours?
No, that made a lot of sense. Thank you.
Oh. Let me go over. Demetrius, I will let Stuart know. Hey, Sarah, any other question about the contour?
No, that was all. Thank you.
I'm not sure if we can hear you.
Oh.
You
Can
try
you hear me
again?
now?
Yeah.
Yeah, no, that was all. Thank you.
Okay, cool. Let's move forward to the retention then. I see one of that here. Let's see. Let's look at that one. So you have a big retention area. It's the same issue, right? The black line should not be the boundary of the retention. It should be the one of the contours of the retention. So we look at the elevation over here. It looks like it's going to be about, 7.6, something like that, 7.7. And your LP would be a little bit too deep over there. You have an RDI. Well, big picture first, okay? I'm gonna zoom out. So we'll have to check first if this is the lowest point. Looks like close to the lowest point. No, pretty much correct. Maybe off a little bit. So you want to find out the lowest point along this edge, and that's your curb cut elevation, okay? And your curb cut elevation would be lower than 1108, because if you remember what we drew, we had a contour like this, right? That's your 108, and it wraps around. This is a close contour, but here you would have a lower than 108 elevation just because that point is below the 108 contour. Looks like could be 7.6, something like that. So here you would have 1107.6 as the entrance of the flow. And then this one is the entrance of the flow from the other side. It's higher, right? It is higher because it's on the plaza and it's close to 108. Let's say is 107 point something like, no, 8. So we're actually mixing, dirty water with clean water, which is not a great thing. We need to try to avoid that. I know you don't have a lot of space here. So let's zoom out. Oh, and then there is another thing that you actually have some water. Well, keep flowing down. So that's okay. Eventually gets out of, well, if possible, you would want to try to cut through here, okay? No, having some curb cuts over here because you have a big open space in the middle and we're not using it for now. And we should try to use it. And then you can have a trench drain, right? I know you have a sidewalk over there, but you can have a trench drain that goes across the sidewalk. So you can try to treat the water from this part. All right. And here is the lowest of the turnaround, meaning everything excessive. No, all the runoff that wasn't able to be treated by previous curb cuts will eventually come here. So you would want to try to create a bigger area. Likely you will, make use part of that area. Well, let's stay off the swale line, because we don't want dirty water to be mixed with the clean water. So you'll try to create something that goes around, but here you have such a small, I would say you have such a small drainage area there. It's probably only taking a pretty small one on the side. Does that make sense? You can only you can use just a pretty small one for the other half of the lower half of the plaza, because it's pretty small contributing area. Does that make sense?
Yeah, that makes sense.
Okay. So let's zoom in and look at how should we design for this one. Again, we're aiming for a bigger one. Try to connect this big. Okay. And now we have 1107.6 estimated. And RDI would be lower. LP would be 6.6. Okay. RDI, you could make it 7.5, and then your LP actually can be 6.5. That's your RDI, 7.5, close to the entrance, and your LP would be 6.5. And 6.5, you have, now we need to look at the contours nearby, right? Like we did before. We have an 8 coming, hit the, that's our 8, hitting the building and the curb. And then the 8 needs to keep going and connect to original 8 somewhere here. We have a 7 contour definitely in between. So we'll just say that the orange, the green here is 7. So you have an 8 and a 7, meaning that you don't need a berm, but you will eventually need a berm between the 7, okay? The next contour is a 7 contour. It goes somewhere down and then connect over here. So you need a berm in between your retention and the 7 contour. And then we said, let's do another one like here, treating the plaza water. I'm gonna move this a little bit over so I can be in touch with my plaza water. Please. That want to clear. Sorry, not able to clear just the portion of that one. Well, we'll leave it there. The key is I have to have a flow of some sort that will lead water into my small one, okay? So I'll calculate that one. This one would be 1107.8. And then you do the same thing, right? The RDI would be 7.7, LP would be 6.7, and then this one would be 7 again. The contour here will be 7 again. This is 7. And I have more HP to make, just creating that berm for both of these retention areas. Does this all make sense?
Yes, thank you.
Okay, cool. So that's this portion. Let's look at one more. Which area do you want me to try to look at? Here?
Yeah, that's fine.
Okay. So we have a curb cut going over here. Looking at the location, I would say this is a dead end, right? You need some sort of a cut over there because some of the water will be ponding here because it could, like everything, this drainage area, it doesn't go anywhere. But well, if we don't have any cuts, I'll say if we don't have any cuts, you actually have a pretty big drainage area of that big that goes into the corner, right? So we have to have a curb cut at the lowest point. That's a dead corner. What are other places you should cut? You can't cut it here as well. That's a relatively lower part, so that's good. Now, if we look at these 2 points, 109.2, and that one should be 1109.4, something like that. And then you have an RDI of 8.75, 7.5. Okay, your water level exceeds 1 foot. So you do need to raise your LP, okay? Raise your LP so that it would be no more than 1 foot below your RDI. And you will have a 108 contour here. So the contour that you drew here is an 8. Your 8, you would have both you'll have both of a 9 and an 8, sorry. So this one that you drew is 9, but you have another 8. Yeah, because your LP is below 8. So you have 2 contours, 9 and 8. And between this 9 and the 9 that's over here, you would have HP. That's correct, right? Make it 0.5 so that the berm is not too high. Yeah, that's all the revisions necessary. You need to cut this open, raise your LP, add an 8 contour, lower the HP by a tad to 109.5, and that's it. Does that make sense?
Yep, thank you.
Okay, cool. Very quickly move to your third, just glance over. Same thing, you wouldn't have a curb cut here because this is plaza. You don't have a curb at the edge of the plaza. And this one needs to be on your swale, okay? If you want something here, you can actually change your swale line. If you want to change your swale line so that it goes through a relatively open area, you can do that. You just need to turn one of the contours like this, okay? So that this angle is the same as that angle. It's not it's actually, it could be a good change for you, but also you could also leverage the area here. So, okay, you don't necessarily need this one. You don't need this one just because you have a green area already in this area and it goes through, see, your swell goes in it. So use this area as your retention. No change of these, but instead, that's your entrance, okay? So it might be 7.6, something like that, and then you will make your retention in this area. This contour stays here. This contour stays here, but the shape of the contour can be changed, right? As long as the connection of this contour to the sidewalk stays the same. That point, the connection point stays the same. The portion of the contour in the green area, you can feel free to change it, okay? All right. All right, I'm gonna move forward then.
Okay, thank you.
Let me grab a bottle of water. my okay, page. Wow, I don't think any of this looks right. So how do I know how big the bioretention area is supposed to be? So yeah, if you remember the rainbow exercise, those are the absolute minimal that you need to have, right? Because that helps treat 1 inch of the dirty water. But at this stage, the shape will be more, curvilinear, but you can, if you have space, you can make it as large as it can be. You can make the best of any available space you have, but you cannot go smaller than the one that you have. We would not check the numbers, but over time, we kind of have a sense of whether this is too small or not. Yes. Use the rainbow one as a reference, but you don't need to be exactly the same area as before, okay? Okay. Very confused about the plaza. How do I add if the swell is there? You actually add holes along the swell, right? We can take a look at one of the areas. Now you need to wrap the contour around the retention area. Yes, yeah. Okay. Doesn't seem to be right. Yeah, you need to move the contours around it. We'll take a look from up to the bottom. 4, 5, DIBC equals to, well, that's too high. Based on the location and the distance between your 1106 contour and the lowest point, it's probably 110685, 0585, okay? Yeah, those needs to be calculated. So this is likely 05.85. After that, your LP, that's fine. And then you would have if your LP equals to 05, you would only have a 5 contour. You would not have a 6 contour. That contour should be 5, and it's pretty small. Let me zoom in again. So that's a 5 contour. Right. Yes. So you would have a 6 going like this. Right, correct. The area in between would be higher. Well, depending on whether you have paved surface or not, this area, if it's not paved, it can be flexible, like you can do something like that, okay? So you only have a 5, and the 5 is pretty small because the 5 is the bottom of the cell, because your LP is 5, right? 5.0. You have B, you have a DI, and you don't need a RDI. And yeah, that's it. This is it then. Yeah, yes, yeah, okay. All right. We'll take a look at this one. This one is could be a little more complicated. it's not very clear where your plaza line is. So we'll need to add that back. Looks like it's going to be somewhere. Looks like it's bigger than somewhere here. I'm not sure, but sure. Yeah. Yeah. Don't forget to add back that plaza line. Okay. We have 107. If you're on a plaza, you do not need HP because the HP is to create vegetated berms, right? So if you're on a plaza, you think of, I first pave everything, but then I took out some of the pavement, I have a hole. Not necessarily. I should, well, maybe it's beneficial. We provide a few pictures of what this could look like, right? It could be, if I drew, I have a plaza, and then I have something of a hole here. If I have very small area, it's actually good if I have vertical walls, right? Change the color. Basically, this is a hole that well, I shouldn't make it like that. I should only draw something like this. And then if this line continues, well, it's a pretty gentle one. So I'm gonna do this and then draw another wall. This is my depression, but if I want to make it more multifunctional, I can actually have a bench over here. And that would be my wall. And probably make it the same height as the other one. I can make a sitting wall over here. I could design something like this. Now, when you construct it, the sitting wall actually goes to the bottom of the cell. So you would represent them on your plan as retaining walls, right? But you don't have to do that. You can basically have a depression. It could also have sloped side if you have enough space. You can see that if I have a pretty small one, if I need to use a sloped side, you don't have a lot of storage. That's the reason why a lot of ultra urban setting, when you would have planters with vertical walls, because with a small surface area, you get the bigger volume, right? So in your case, this is a pretty small area. You could make it vertical wall, okay? If you measure, for instance, a 3 foot in offset or offset another circle, and that area is still not too small, maybe you can do the slope side, but no, in your case, I would probably just do a vertical wall. So that's what it looks like in cross section. We don't need to have the sitting wall, so I could pinch it down like this. But you can see that water gets in from here. It gets out. If I don't have my RDI somewhere, it gets out from the other lower side, right? So you need to be mindful. This is actually one of the harder ones because it will spill over if you don't have a berm of some sort from there, right? So you have a solution of saying, I'll just raise that one, okay? So then I can raise my water level. You still want that to be slightly lower than the edge because you are on a plaza, you don't want it to spill, right? So you would calculate both of these, and then you decide, I want the green wall or the orange one to be raised. Then you can use the first point, the higher point, a little bit lower than that as your RDI, okay? So your RDI would be at this at this elevation. If we do a pretty quick estimate, this might be 6.8, so 6.7, something like this. So my RDI would be 6.7, okay? And then that means, yes, I would have a wall. And then you would need to represent the wall. You would use B wall and T wall, okay? RDI is 6.7, meaning that your LP here would be 5.7. And then you would have a 6 contour. That's your 6 contour. You had it. Good. So the bottom of wall here, you would say B wall would be 5.7, and top of the wall would be, in this case, you want to be at 7, okay? At least 0.25 above your water level. So your T wall will be 7. You would not need any of the HPs. You would need an RDI, an LP, a 6 contour, and the B wall and T wall for both of the sides. Okay, it looks like you're designing a continuous, like a wall, but you don't have to have the wall wrapping around all of them. You could have a small wall like this on the lower side. That's your berm. Yeah, that's your berm on a paved surface. Okay, good. All right. Let me zoom out. We got through 2 of them. Let's look at this one. Yeah, a good example. Okay. I'm not sure where the pavement ends. You have the similar situation where you have one dirty water here and then another one. You can be pretty small if your paved area is not too big. So if you have a pretty small plaza, that one can be here. Or if you have bigger plaza, that one can be lower. But we try not to mix them. Okay. We'll look at this one. So curb cuts 1106.5, good. DI, BC, good. I'm confused. Okay, your DI should be 1.1 lower than your curb cuts instead of higher. So this one is lower than these ones. Yeah, so the DI should be 6.5 and your curb cuts should be 6.6, all right? You can verify those calculations. LP makes sense. In this case, you wouldn't have a 107. Your 107, you would have a 106 within your retention, right? Because everything is lower. Your curb cut is lower, your LP is lower, so you don't have an 07 just for your retention. But your 07, I know it goes like around and this, right? So that's your 07. And this darker line should be 06, okay? Should be 1106. And then your 06 is over here, which means your berm is over there. All right, cool, good. Okay, anything else? That's it, good. Well, it's starting to look pretty polished. So good job on arranging the elevations. The size of the spot elevations are pretty good. Some of them are aligned with for instance, these ones. You don't need to change them. Yeah, you don't need to change them. Make them consistent. Yeah, okay, cool. All right. Sarah over here? No? Okay, well, I'll do Jake's first then. It takes pretty long to review each submission, so we'll prioritize whoever there are here. Okay. We have a change trend situation here. Good. Let's do the bigger one. I'm intrigued about that one. Okay, curb cuts over here. Okay. I have to say I'm a little confused. You seem to have designed a bigger one, but I think you need to divide them because your water enters at a different elevations, right? The first water, you would need curb cuts over here and there because they are pretty much dead corners. If you don't cut it open, it will pond, right? So those are at about 11.89, something like that. These are 11.9. And that seems to be right about 12. Okay, so those are some of the high entrances. You need to think of the whole thing is slanting down. If you don't have berms in between, it will keep flowing down, right? It's like this surface keeps going down. I have to create some berms in the between, then I can have a depression over, sorry. Then I can have a depression over here and depression over there and another depression over here. Does that make sense?
Yeah.
For the first one, yes, that's correct. Because you have your trench drain entrance, and you don't have another mechanism for it to overflow. So in your case, you do need RDI for each one of them. Yes, that's right. So I'm gonna erase this. And then take a look at where water are entering from other places, right? So this is going to that way. So that's your entrance. And that is another entrance from here. It cuts through the sidewalk over. And these entrances, you think about the trench drain, you need to calculate the surface of the trench drain first based on the parking lot, right? So that's exactly where you have the location here. Sorry. So that is close to the 11 contour. So the surface of trench drain would be 11.15, for instance. But your trench drain has a depth, right? The trench drain has a depth. You can make the depth about 6 inches, okay? So the bottom of the trench drain, you would use that to minus 0.25. Oh no, 6 inches, 0.5. So you would have 10.65. That's your bottom of the trench drain. Does that make sense? So the water entrance here is actually 10.65. You use the same method to calculate that one. So this means you would have a berm somewhere here, another berm somewhere here. In between these two, you have one cell that's connected to that, another cell connected to this, and a third cell connected to that. Okay, and then you need berms in between them. And then these elevations are decided by the lower elevation, right? The entrance is 11.9. So that means your RDI would be probably 11.8. Your LP would be 10.8, okay? For this one, you have a pretty low 10.65. RDY would be 10.5. Your LP would be 9.5, right? You basically, you use those numbers to guide what contour do I need, how high the berm needs to be. Okay. You don't need them. You don't need to. So here is sort of the rough grading. You get a general picture of yeah. If the details would be included in a separate drawing, but we're not emphasizing. We're not getting to that level of grading yet. Okay. Okay. So that's that one. Let me try to clear. Yeah, I would say yours are pretty difficult. Things that you do need to keep in mind, I want to say one more thing. These connection points cannot change, right? So your 10, you still have the 10, you still have a 10 going inside. You can make it curvilinear however you can accommodate the contours of by retention, but you have a 10 here. Otherwise, your 10 wouldn't be able to close. So these 2 points stay the same. And the 11 stays the same. Okay, those stays the same. You would have 10. Oh no, that's actually 12. Yes, that's your 12. That's your 12, and your 11. Those roughly connection point cannot be changed, but you can curve it like this so that you have a bigger cell here. All right, you can curve it like that so that you have a bigger cell over there. But you don't change. You cannot delete the 12 and the 11 and the 10 from the center area. Okay. All right. All right. Let's take a look at one more here. Yeah, you would have another one in the middle. The same idea. Here would be, you could curve it. No, if you want the upper to be bigger, you can curve it so that there is a cell over here, right? You can even make it very close to the curve over there. It just there means that the lower side would be steeper. This is the 10, right? So you have another 10 over here in the retention area. Yes. Yeah. For this one, again, you don't necessarily need an REI because still water can keep flowing down. You need curb cuts. The absolute lowest point is over here. So you don't need an RDI here. You can put it in, but it's not necessary. Just because you still have, the water just can keep when it's full, it keeps flowing down, right? It doesn't have to enter an RDI there. Okay. All that it's lacking in this one is a contour. Okay. All right. DI needs to be at the lowest point, as we discussed, at the lowest point there. This seems pretty low. I'm not sure we need to go that low. If this is 09, very likely you will have an 08 something here, not 07, because you don't have an 08 contour here until this point, I think. Well, the contours here doesn't look, let's see. Let's take a look. Yeah, it's a little over graded in this area. Once you put retention here, things will change for your 06 and 07. Most likely your 08 doesn't need to be dragged up that much. Okay, your 08 could do something like this. Very likely you don't need to drag it up to create that swell. There's one more lecture about divergence swell. it will change drastically what this area look like. So I wouldn't start changing it right now. I would wait until the divergent swell lecture is given, and then I'll work on this area. Okay. It's similar idea. It's a similar idea to what you have here, but it will try to integrate your divergent swell here with your bioretention on the side. You would have retention here, right? So it will better integrate these together. So something will change, but I still think the swell here might not need to be this long. Once it gets to somewhere here, I think it can end. So your 03, 04 most likely will just sheet flow hit the retaining wall, and that's it. Okay. Yeah. Yeah, I think we talked about this. I think we're off by one contour here because this is 09. So that's 8 point something, 8.8 even. So your RDI would be 8.6 or 7. You can cut it bigger though. You can make it bigger. You can make a shape of this thing. Make it bigger, then it will be worth it. Yeah, a really small one really might not be worth it, but you have the space. You're not influencing traffic flow going down here. People can go around. So I wouldn't actually move it over a little bit. Be mindful about how people will walk. So if I delineate the walking path, and it actually makes sense to make it here, right? Because the sidewalk is over there and the sidewalk is over there, and people might be walking in the middle. So I have a pretty good shape and spacious area in the middle there. Okay. Anything else you want to go through? Okay, the bigger one in the middle. Yep. You would look at where water drains into it, right? For instance, this one, I'm saying if this is the area that you're receiving, it might still be worth doing something. For that one, I wouldn't do anything just because that's the small area. This is the area that it treats, and it doesn't really help that much. I don't think it's that necessary. For this portion, you can have the cut starting here just because, let's see. Water enters here and there. That's probably the only entrance before it can, yeah, it's still worth having some cut, on this edge. What about, yeah, we have one of those there. There's no point to cut anything here because it doesn't really receive a lot of water up until this point, I would say, because you can still receive quite a bit, right? So yeah, the corners of these two islands, you could cut it open. And the corner of that one, you could cut it open, but I wouldn't do more than that. Okay, we're good? We're good, okay. Carrie. Okay. All right. Is this how you do it on a swale? I see this might be something, is it a leftover? The DI over here. We're in a vegetated area, so we don't need a specific feature to treat the vegetated slope. So your treatment would actually be somewhere over here. That makes sense? So yeah, you would have curb cuts. In your case, if you have sidewalk, you would have trench drains going through the sidewalk, and then your retention would be closer to the road. Okay. So that's that portion. Then we'll take a look at for your, I would do 3 along this. So that one and this one, probably move it over a tad, and then one more over here. Okay. And then for this one, this is on the plaza. Yeah, this is on the plaza. I think I went through with Paige about, how do you do one on the plaza? You have a pretty big area, so I don't think you have to do a wall. Do you want me to go over that again, or do you think you captured that? Okay, so this is on the plaza. When you're on the plaza, it's actually a little harder because your plaza keeps going down, right? If we're cutting a hole, if I don't do anything, I can only retain this much water. Does that make sense? Yeah, so you have to calculate. You need to know the exit elevation. So calculate the plaza elevation at this point and at this point. If you have a pretty big retention area, maybe even if the water level is at this level, you still would be having enough storage. But you can see how if I add a short wall here, how I can actually raise that and raise this. Does that make sense? And that make it look better, because normally people would not want a pretty deep hole like in the middle of a plaza, right? What if the kids fall in it? So it will be beneficial if you have a short wall over here, and that actually serves as the berm if we are working on the vegetated area. Does that make sense? So you would look at these elevations and decide how deep you want this to be. You want this to be, right? The bottom. And then use that to guide your water level. Your water level is your RDI level, right? And then use that to decide the T-wall here. If you decided all these, the B wall will be the same as your LP. Does that make sense? Yeah. So this is how you do a retention on a plaza. In your case, okay, I'm trying to figure out the contour number. Contour number is really important. So we need to always remember to label those. Otherwise, it's really hard to. So this is 8. This is 7. So this might be 7.6. And that one might be 6.8. Okay, so that means I have a 7.6 over here. I have a 6.8 down here. Then if I say I want my water to be 7.4 or 3, then my LP is 6.4. Then I would have a 7 contour. I have only one 7 contour there, right? And then the TW can be anywhere, no, it could be above 6.6, 7.6 or 7.7. And the bottom would just be, the bottom of the wall would just be 6.4. Does that make sense? So all these are what you need to label here. You need an RDI, you need a 7 contour, you need elevation at the entrance, and you need T wall and B wall at the exit there. All right. Yeah, I think I didn't miss anything. Okay. An enclosed, yeah, an enclosed contour of 7. Seven contour would be just, you just need one contour in the middle. Okay. All right. Okay. So that's that one. Yeah, I won't be able to assess these because the elevations are not calculated, but most certainly you have more contours than necessary. You would only have one contour because unless you want to make it really deep, it is 1 foot high in terms of water depth, right? So normally you wouldn't want to make it very deep and having 2 more contours. Okay, you would only have one. And then I would say I don't see berms, so most likely those needs to be added in some cases. Okay. Yeah, it's actually better if you copy TC and BC over instead of FFE, because in this case you need to actually delete them and then or you need to retype them. So it's better if you know not copying or delete these and copy TC and BC over, but TC 0000. Otherwise, you would easily forget which ones I have calculated and which ones are not. It's going to get very busy. This drawing is going to get very busy, and it's going to be hard to keep track of what you have calculated or not. Okay. Okay. Other questions you want to go over? If you the best person to get information would be Jonathan. If you want us to while you discuss with Jonathan, but you can discuss with first and get a sense of why. And if you think that should be taken off, you would follow the procedure and say, I think these should not be detected, and you send that to reassure, and then we will adjust if we agree with it. Okay. Yes. Yeah. So for this one, you have a pretty similar situation with, I think it was Sarah's that I went through. You have the lowest point over here, so your curb cut needs to be over here. Again, the cut needs to be at the lowest point. Otherwise, you will have plenty of lowest point, right? So you need to cut through. I don't know what that double line is. Oh, you have a sidewalk. Well, that sidewalk line would not be there anymore because you have a plaza, right? Yeah, so you don't have sidewalk anymore here. You have a curb and then you step up to the plaza. So here is your curb cut area. And then you need another one over here. So you have a cell somewhere here and a cell somewhere over here. And then a plaza. Oh, okay. You need to cut through the whole thing. Okay. Well, you have a few options. You can get rid of this plaza line and say my plaza goes around. My plaza goes around like this. And then somewhere you connect to the stairs or your ramp over there. Otherwise, it needs to cut through the parking, oh no, the plaza. Well, let me zoom out and see. Okay. Okay, it is fine. It is fine if you cut through. So then I would suggest you do this. Curb cut over here, retention area there, a cut in the plaza that just deal with the dirty water from the parking lot. And then your swell line, at the bottom of the swell line, you have another one that deals with the clean water. And your plaza line can stay here. Okay, your plaza line can stay here. Basically, this is a hole, one of the holes in your plaza, but it only receives the dirty water from the parking lot. But at the end of the swell here, you have another one that receives the relatively cleaner water from the plaza. Okay, all right. All right. I would again try to do one more, at least during class time, because you don't have elevations here. So I'm not entirely sure. If you try on your own, if you can get the elevation. Does that make sense? Yeah, if you can work on one of them, get your elevations ready. We can help review one more time. Then you can take that away and say, I will be confident that my elevations and contours will be correct. Because you have probably a dozen to make in this exercise. And if one of them is wrong, then you probably need to start over. Okay. Okay. I see Sue over here. Sue, can you unmute so that I know you're there?
Yeah, I'm here.
Okay. So I'm going to take a look at one of the cells over here. Okay. We're not treating, I don't see a clear connection, I would say, clear connection between your sidewalk is definitely too wide. And it's almost 10-foot wide. You could have a 10-foot wide sidewalk in areas where it's essential, but I don't think you should use the space for a 10-foot wide sidewalk on that side. The reason being, people get off their car, they see the building, unless there is some destination, wonderful things, attractions over there, you wouldn't be able to attract them over to that site for them to use the sidewalk. So I think we can get rid of the sidewalk. It actually saves space for your retention, okay? Now, if we take a look at where we need retention, for instance, this location would be very critical. You have a retention because that's one of the dead corners, right? And these locations, those are the dead corners. So if we say we want a retention connected to this curb cut, then we'll calculate this curb cut height first, and then move forward in determining the other elevations. So we'll look at one of your retention area, and I'm not clear where water comes out of the curb. If you have a curb cut over here, well, the curb cut, we need to look at the elevations first. again, label your contour so that we know which one is which one. This is the 9. That is the 8. If you have a curb cut in this area, it wouldn't be at a 1106 elevation. Okay, it will be at a 1108 elevation. Okay, the curb cut elevation is exactly what the surface elevation is on the parking lot. Right? So here you would have an entrance of 1108. And now if I zoom in, if you have a 1108 entrance, you can have an RDI, but you don't necessarily have to have an RDI. Then your RDI, the 1107.8, something like that. And then your LP will be 1 foot below that, will be 6.8. Okay, so here you cut this open, you would not let the water run on a vegetated slope and then get into a retention. Okay, you want to contain them first. You would not want the water to run on the surrounding surface without control, right? So your retention would be in this area. Oh, sorry. It's really hard to draw with a mouse. With this area, your curb cut will be 808, RDI will be 7.8, LP will be 6.8, and you will have a 7 contour. This is the 7 contour, okay? And now you need to look at where the other, well, contours are. So if this is 8, your 8 goes like this, your 7 goes, oh no, correct, sorry, wrong direction. The 8 goes like this, right? So your 8 goes like this. If that's the case, then you don't have any HP anymore because your 8 is correctly on the higher side of your 7, and your 7 is not adjacent to any other 7s. So that's why you don't need you do not need a high point. If for instance you want to do, well, let's forget about the other option. I think that's more, that will complicate things. But no, you have 7, you have 8, you have 9 on the other side. You have a 9 here. That's why, oh, give me a second. Your 9 is over here. Your 8 actually needs to wrap around over here, and then your 7, 8, 7, because you cannot have 7 and 9 be the adjacent contours to each other. You have to have an 8 in between a 7 and a 9. And so that's the reason why why you would have high point in between 7 and the other 7 on the other side. Your 7 goes somewhere in this area and connect back like that. So yeah, you would have a high point between these two 7, but not between the 7, 8, and 9. Does that make sense?
Yeah, thank you so much.
Okay. Same thing here. This needs to show a clear association with your curb cut, or no, so here you would have the curb cut over there. The swell line seems to go this way. So I'm kind of sure that your contours are not correct in this area. Okay, we'll need to do a little bit of a change to the contours. We'll try to, so your 8 goes like this. That's your 8. Your 8 goes like that. okay? And your swell goes like this. And that's the reason why the contour here needs to be like this, okay? That's a closed contour. If that's the case, your curb cut needs to happen there. That's the lowest point of your swell. And your retention needs to be, the retention needs to be this in this area. Actually, you have a pretty sizable green space there, so that's a pretty good location. But your retention design needs to be based on that elevation, okay? The curb cut there would be 6.8 something around that area. So the entrance of the water flow would be 6.8 there. And then use that 6.8 to design the subsequent LPs and RDIs. Okay, so that's that one. For this one, again, you would outline where your swell line is. The swell line is over here. So yes, your retention is at the right location. Okay, but you need one more. You need one more for the dirty water that comes out of this area. Okay, so we can cut a hole in the plaza. Let's see. Again, I'm not exactly sure you need this sidewalk. I think you can end your plaza. Oh, sorry. You can end your plaza somewhere here. And then in that case, you can cut through. You can cut through your cut through some of the pavement and then have a small trench drain that will help you use this space as your retention. Okay. You still have some mix of dirty water and yeah, okay. So how do I avoid that? It's likely going to be hard for you to avoid that mixing of the water because your swell goes right through. And I don't actually want to switch your swell direction because otherwise it will get pretty close to your building. So I guess in your case, we'll have to live with that. So you would have some mixing of the dirty water and the clean water. The location is good, make it big.
I have a question. Do you think I should move the building then so that I can avoid that?
I'm sorry, I cannot quite hear you.
Do you think I should move the building then to avoid the mixing of water? Like, would that solve the problem?
Yes, if you rotate the building, to that side a little and push it back, then you would not have that problem. So basically, I would say that one would be smaller and closer, and then I would shift this around to here, okay? And then I would have my this line being turned, not that one. This line being turned to like this, and then my building, I would have my building doing this at least. Then there's no water will come into my building. I can even move it closer a little bit like that. That makes sense? So in this case, you wouldn't, in this case, you wouldn't have any water getting into your building. It's not close to the entrance to the building, and you could have a separate retention somewhere here, and those two wouldn't be mixed together. Okay?
Okay, thank you so much.
Okay. So did I answer all your questions?
I just had a question about like how to rotate my text because like with some of the contours, I guess it gets too
Oh, okay.
close. So
Your
I don't know how to
text.
like position it.
Or your text would be exactly the same direction aligned with the bottom of your page. Okay, all the spot elevations, not all the text, all the spot elevations would be aligned to the bottom of the page. They will be the same direction. Your other text, your contour numbers and your slope numbers, they can be turned to other directions, but not your spot elevations. Right? Your
So looking at like exactly like where you, that
yes,
one
yeah,
by
it will be
retention area,
aligned to the bottom of the page.
okay. But like some text is like facing one side and the other is facing the other. Like, does that look fine? Oh no.
No, all the spot elevations would be exactly like what I typed here. Even if you feel, well, TFFE could be an exception, but for your retention, it will be exactly like what I'm typing here, 1106.5, for instance. It will be aligned to the bottom of the page in the same direction. Okay.
Okay. Thank you.
Yeah. Yeah. Other text can be more flexible. Okay. Good. Logan. Good. Okay, to somewhat correct. Does there need to be a certain shape? No, it doesn't have to be a certain shape. But we would want it to be, again, these are okay, the lines that we drew on these planes are complements, they're not yeah, it's really not necessary to make them more complicated for the contour lines because the contractors would not be able to shape the surface in that detail. Does that make sense? Yeah. Yeah, based on what, no, from this distance, I can see that some of the overlap, you need to mask all your text. Otherwise, the overlapping will make it very hard to read. And remove the rainbow exercise lines. Remember to turn off those lines. I know you might have used that as a reference of where your retention needs to be. But for the final product, definitely remember to turn those off. Yes, you're correct. The retention areas are based off the size of the boxes you made for the rainbow exercise. You can make your areas bigger than your rainbow exercise, but not smaller. Is the location of the drop inlet based on where the drainage areas end? Yes, that's correct. Again, they're not set in stone. When you made the exercise 3, you don't have to use the exact location if those locations don't make sense anymore, right? You want to find the locations that makes the most sense and that are able to treat all the water. Okay, for instance, the dead corners, you definitely need those. Okay, let's take a look at your retention areas. So we have a curb cut, 6.8 good, RDI good, LP. Well, you would lower it by 0.1. Okay, you could lower RDI by 0.1 because now your water depth is 1.1, is over 1 foot. Okay. Yeah, and then you would have a 6 contour. That's good. And do you have a 7 contour? So your 7 is over here. You don't necessarily have to have a 7, I think, but let's take a look. 7 is over here. Your 7 goes like this. And then you have a 08 over there. So, well, good. You actually, everything is good here. 7 and 6, and then there is a 7 and 7. Yeah, everything is correct. Your high point are at the right location because they are between 7 and 7. Okay, so that's correct. Yes. Yeah. So your location are currently based on your division of the drainage area, but you could have done the drainage area differently, right? So if it's a tap up or a tap lower, fine. You just want to make sure you covered the whole area. Once you have done everything, you finish doing the side, you will get a sense of how many you have. Let's zoom out and just look at the big picture and say you have 1, 2, 3, and yeah, these feel pretty close, these two. I would, at this point, it might not hurt spread it out a little. Reason being, if they're really close, the elevations are very similar. If their elevations are very similar, then if you create 2 separate gradings for them, it's actually taking more, it's less cost effective because they're too similar, right? They're very close and their elevations are also low. Then it might be beneficial for you to combine them and then create another one a half foot above. So you wanna try to achieve the curb cut of the upper unit would be about at least 0.5 foot above the second unit. Otherwise, they're really close. So you want to try to separate them a little bit so that you don't construct 2 pairs of the same unit that are really close with the same design, because you need to create berms for both of them. That makes sense? Yeah. Yeah, I would do so if you have 1, 2, 3, 4, 5, about 5 contours in this area, you would aim for 4 to 5 units in this area, and then try to separate them out. So you have 1 here, 1 there, 1 there, and probably 1 over here, and then 1 over there. Relative, you can think of the walk along that curve. So it is about the drainage area, how they distribute, and you also need to consider other factors, right? If you are walking along this side, this parking lot, and sometimes you see 2 units are too close, and other times you see, units are more apart and of different sizes, it might break the sequence, the visual sequence of the retention area. So there's a benefit. You kind of try to balance different considerations, not just the drainage area. Okay? Okay?
So, okay. When it does do like
No, you don't need to. You don't need to go back to exercise 3. Yes. Yeah. And then you're absolutely correct where you would have 1 more over here at the lowest end. Yes. Yeah. Okay. So I think you have done a pretty good job on the first one. And let's look at this one. Not entirely sure why you would have a trench basin. Is that a trench drain? Okay. So we'll take a look at this one first. We have 06, and for this one it's sort of the same. We're at the edge of the plaza, so there's no curve. We're just flowing down, right? We don't have a curve like we did. Now previously we're having a curve and then we cut it off. and no, the outside is like this, and then we cut it off, and then we have a green area somewhere over here, right? But now we don't have the curve. We're in the plaza. We're in the plaza, meaning that this is the edge of the, well, this is the edge of the plaza. And then I directly can connect to a green area. Okay, so you don't need a curb cut here. You just need an elevation here. So elevation seems pretty good. 1105.5, already at 4.5, LPA 3.5, those are good, all good. In this case, your contours will be closed circles. Closed, not circles, ellipse, right? Because you don't have a wall. You do not have a wall. Yeah, you do not have a wall here. So your contours basically would just be like this. Closed contour. I'm drawing. Yeah, you see what, you see what I mean. Okay. So you would have a 5 contour for this one. Oh, you actually pinched it down. Okay. You pinch it down for 1 foot. You don't necessarily have to, but you can. So this basically means you made it deeper. Yeah, I think you get the idea. You made it deeper, your water kind of start like 1 foot below your entrance. And then you have another, that's their low point. So you basically made it like this, but you can move this up, RDI up, and then you can move the bottom up so that it's less steep. That's your choice. You can choose to do either, but your water depth, there's no problem with that. Okay. We have 05 and 04. Okay, and then I'm looking for HP. HP works fine. HP works fine. So you only need to remove the cord cut label, make the contours enclosed, and then that's it. Okay. Yes, you need a spot elevation. Yeah, just take the CC and out. Yeah. All right, we'll take a look at the last one. I think you'll get a pretty good idea. So I'm confident that it's reasonable. So we have curb cut there at 110. The curb cut elevation seems to be off. Curb cut elevation, this is about middle, right? Yeah, so that elevation would be 6.5. Okay. And then you just adjust these elevations accordingly. And you have bigger area. In this case, you have a bigger area. You can actually make it bigger. Okay. You need to keep these. You need to keep that connection point. Let's see. So this is, yes, okay. You need to keep that connection point, honestly. If you want to keep this portion, that's okay too. The sidewalk can keep that, that's okay. Then, and we have a connection over here. So basically meaning that this is my 7, right? My 7 can do this as long as I connect back to that point. Okay. What happens in the middle, you can modify it based on whatever you need, how much area for your retention. So this big area can be your retention. Doesn't have to be that small. You have such a big area, let's use it. Granted, admittedly, you have a pretty small drainage area there. So yeah, the small area you have. Yeah, unfortunately, we had all the green area on the ridge. So it's not treating a lot of water, but I don't think we need to change it at this point. Okay. All right. The G is the sidewalk?
Yeah.
Yes, because G drains to, yeah, G basically just drains to E. So was the reason you separate them? E is too big? Okay, okay. No, well, that means you could do something like this, right? We can cut. Like, but at this point, I would basically do a few five retention area at the edge of the parking lot, relatively evenly spaced. That's one of what I will do. At this stage. Yeah. Okay. I think we reviewed all of them. Yeah. Mm-hmm. Oh yeah. Yeah. Mm-hmm. Yes. Yes. Yeah. Well, so we have this turnaround area. You could cut off like this. Just basically you expose. Don't have to get that one out. Makes life a little easier. Okay. And then you could basically have a retention area right here. Right here. You can extend the shape to be sort of like this. No. And then try to direct water away from this. And that means my contour, my 8 goes like, sorry. My 8 goes like this, and then goes like this. Hit my building, right? Hit my building, or you can do a little bit more radical, turning it more like that. And that just means my building would move to a different direction. Will be this direction. Not a huge change. Okay, not a huge change. Turn it by about 10, 15 degrees and then problem solved. Okay. Uh, 6 contour. Did I say 8 contour? That's a 6 contour. Yeah, probably I said it wrong. 6 contour, yeah. All right. Mm-hmm. That's probably a 5. Because your entrance is 5 point something. That's a 5, at least that's a 5 contour. You definitely have a 5 contour, but you can choose if you have higher ones. You will need to look at your contours around this area and say, well, I have a 5 here. Where do my 6 my 6 goes above? Yeah, my 6 goes here. That's my 6, that's my 5, and then I have my other 5 down here. So you don't need other contours. You don't need other contours. All right. I use the blue line. I want the blue line not to go through the green. So I drew the blue and then I mirror it. Okay. Okay, good work. Mm.